Hi everybody. This video today is going to cover lesson 1.2, which is covering analyzing a graph. Okay, so in this video we're going to be talking about analyzing a graph. And when I say analyzing a graph, what I mean is we're looking for the different points on the graph that are important, that give us a lot of key details about that graph. And those points are where it is increasing, where it is decreasing, where is the maximum, and where is the minimum. And so as we look at graphs, we need to think of all of those things. And I also will say that a lot of this information on the notes today come from coolmath.com. They do a really good job of kind of explaining things in ways that you can understand. And I know that a lot of you went to coolmath.com for games and stuff in elementary school, but they also have higher level things. They go all the way up to pre-calculus. Okay, so when we're talking about the critical points on a graph, we're talking about where's something interesting going on. And by something interesting, we mean like the Y-intercept, the X-intercept, the relative minimum, relative maximum. You guys know what X and Y-intercepts are, but relative maximum and relative minimum, those are new terms to you. And so let's talk about the minimum and maximum point, because that minimum maximum point, like at the top, we talked about where is it increasing and where is it decreasing. Well, that's going to change at the maximum minimum point, right? Like if it's going up, then it reaches its max and then it's going to go down. All right, so in this graph, we look at this graph and there's a lot going on here, but what we want to talk about right now are what are the relative minimum and relative maximum points. And then the easier ones for us, because they're familiar to us, is what is the x-intercept, what is the y-intercept. We can do those real easily, right? So the x-intercept is anywhere it hits the x-axis. And so there's actually 1, 2, 3, 4, 5. I only have space for one of them, but there actually are 5 of them. So let's take a second to look at the x-intercepts. On the x-intercepts, we might have to do some approximation on some of these. I'm going to call this negative 4.5. I know it's not all the way there. It's probably more like negative 4.2, but just for our purposes today, we'll just say negative 4.5. So negative 4.50, negative 20, 10, 30, and 4.5, and again, maybe more like 4.70. When we give those, we want to give it as a coordinate. So if I ask you what is the x-intercept, don't just say negative 2 is the x-intercept. Say negative 2, 0. All right, you have to give the whole name of it. The y-intercept, there's only one. In this case, it is at 0, negative 2. Okay, let's take a minute to kind of read through here, because those are the intercepts. You guys know about intercepts. Again, we state it as a coordinate, not just a number, but a whole coordinate. But let's take a look at this. It's talking about relative max and relative min. The tops of the mountains are the relative maximums because they are the highest points in their little neighborhoods relative to the points right around them. So sometimes they're called relative max. Sometimes they're called, there's another name for them. I'll come back to it. So a relative max is here. That's the top of the mountain, right? That's the very highest points. That's the relative max. This one also is a relative max. And so you can have more than one relative max. Relative extrema, that is maxes and mins, are sometimes called local extrema. Okay, so sometimes we call it a relative max, sometimes we call it a local max. And again, it's just the top. That makes sense, right? Now, over here, this arrow, it's pointing up forever and ever and ever. It's not the relative max, that would be the absolute max. The absolute max is going to be positive infinity. And then for the minimum points, they're the bottoms. So this is the relative min. Oops, I need to rewrite that. Relative min. And this is a relative min. So those are our relative minimum points. And so we can point to it and say, here's the max, and here's a max, and here's a min, and here's a min. But if you wanted to tell someone without pointing them, you'd have to be more specific than that, not just here, but where. Well, when we talk about max and min, we talk about the y values, right? Because if this was like, I don't know, a graph of profits, let's say, what was your maximum profit in this decade? Well, the relative max is 2, right? It got up to 2. And what was the relative min in such and such decade? Well, it got down to negative 3. And so when we talk about relative max or relative min, we really just use the y value. And so that's written out here. The f has a relative max of 2 at x equals negative 3. So there it is. That's my relative max. And where is that? Well, it's at negative 3. And f has a relative max of 1 at x equals 2. So again, here's my max, got up to 1. That was at positive 2. And that part of it, that y value part of it, just throws some people off sometimes. Like if we have a test or a quiz and I'm asking you what is the maximum point, you really just have to give the y value. I'm going to try to explain that one more time in context. I feel like sometimes when you're just talking about math by itself, it can be a little bit confusing, and if we try to put a story with it, that might make more sense. And so this graph is from it's from a little journey to the bus stop. So this person's going to the bus stop and they walk along and they get here, but then they turn around and they go back home, and then they run faster to get to the bus, and then they wait. Okay, that's what is going on here. Most real world graphs have x-intercepts and y-intercepts at 0, 0. And that's part of our lesson today is where's the x-intercept, where's the y-intercept? Well, here's the x-intercept and the y-intercept at 0, 0. Okay, if we look at this graph and we asked what is the maximum point, maybe what we're not asking is what is the maximum point, we're asking what is the maximum distance from home. And there is a relative max here at E, which is at 100, and that happened at the 50-second mark. So there was a relative max there at 100 at 50 seconds. And then the maximum distance, this question was what's the maximum distance? Well, the farthest away they got from home is 160. And I guess we should put a label with it, meters. We can put our meters at our 100 as well. And so at point E, the relative max, well, now we're talking about E. At point E, the relative max is 100 meters. So for the graph above, let's look back at that graph above. The relative max is 2, not 3, 2. So we're talking about this one right here. This relative max, we would say it's 2, not 3, 2. Okay, let's turn the page. Okay, the min, we talked about that on the other side. The min is the bottom. So here's a min, and again, we don't care about those because that would not be the relative min, that would be the absolute min. And so the relative minimums are the lowest points in their little neighborhoods. So here's a minimum of -3, and here's a minimum of -1. Because in this area we're talking about, there is a minimum there. So it has a minimum of -3, where? Well, at x equals -1. And this has a minimum of -1, where? Well, at x equals 4. So we want to focus our attention on the y values. So those minimum maximum points, I'm going to go back to that graph for just a second. Those minimum maximum points, they are like a delineation, they're like a stopping point, right? So this graph is going up, 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 up until here. And then it turns around and goes down, 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 down until here. And then it goes up and then it goes down. And so those min-max points are where it turns around. And so in coolmath.com, they use this little ant, and they name their ant Pierre. And they call it Pierre the mountain climbing ant. And so this is Pierre, and anywhere that he is crawling up, and again, he only goes from left to right, anywhere he's crawling up, it is increasing. So if Pierre is climbing uphill, then the graph is increasing. If Pierre is climbing downhill, the graph is decreasing. Let's take some time to look at this again. We're going to talk about the x-intercepts and y-intercepts because those are part of our critical points. And again, we have 1, 2, 3 x-intercepts. Take a second to write down those x-intercepts. All right, once again, we have more than one x-intercept, and I called it -4.5. I'm being very general here. It's probably more like -4.2. But I didn't just say -4.5. I said -4.50. And here's our 1. I'm not just going to -1. I'm not going to call it -1. I'm going to call it -1, 0. And then here at 3, 0. The y-intercept, there's only 1. And actually, it's not marked on here. We can pretend like it is. Let's just call this -1, for instance. But there's a reason for that. And I'm going to call it 0, -1. The reason for that, and that's because oftentimes we are not very concerned with how high it's going and how low it's going. We're just concerned with, is it going up or is it going down? Okay, but that we don't need to get into that today. So when we talk about increasing and decreasing, we use interval notation. So where is it increasing? Well, we also always use our x values to describe it. Okay, so from -infinity, this is the x values, because over here in x's, this would be -infinity, and in the x's, this would be +infinity. So in the x's, from -infinity all the way, Pierre has been climbing this whole way from -infinity all the way over here, all the way he's going up, 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 all the way up here to -3. All right, now the question is, do we use brackets or parentheses? Well, for infinity, we always use parentheses. And for the top of the mountain, if Pierre was standing right here on the top, would he be climbing up or would he be climbing down? I would argue that he would be neither up or down. He would be being flat. So Pierre, if Pierre is standing here, he's just going to be flat at that point. And since he is flat and not going up, because this is increasing, he's not going up. He's not going up at the -3. He's going upwards right before the -3, and right after the -3 is going downwards, but on the -3, he is flat. There's one more place where the graph is increasing, and that is from here, from 1, all the way over to 4. And once again, we think about, okay, should we use brackets or parentheses? Ooh, this is a tricky one. This is a tricky one. We're going to put rounded on the +1 for sure. That's definitely rounded, because if he was standing here, he would be flat. Gets up to the 4, and at the 4, I'm going to say he's not flat yet. He doesn't actually get flat until right after the 4, like 4.001. That's when he gets flat. Okay, again, we're describing with x values. That's important. Parentheses is always going to use, infinity is always going to use parentheses instead of brackets. For increasing and decreasing intervals, use the parentheses because at that point, Pierre is not going up or downhill, he is going flat. So that's how we use interval notation with our increasing intervals. Let's turn the page. Okay, how about downhill? It's going to be the same basic thing. Pierre is going downhill. How far? Well, from -3 all the way over to 1, he's going downhill. And we're going to use parentheses because he's at that place, he's flat. At this place, he's flat. But in between, he's going down. So that's our decreasing interval. All right, last example, and there's a lot going on here. Okay, notice all they have labeled are the x-axes. That's going to actually help us in this. Take a second to label all the tick marks here. X-intercepts, there's a bunch of them. Y-intercept, it's hard to tell. So you know what, we're going to skip that. I think we all know X-intercepts and Y-intercepts. I hope you do. By now you should know those. But let's talk about increasing intervals and decreasing intervals. Let's take a look. Where would Pierre be going up? And where would Pierre be going down? Okay. Another thing is with these, we always want to use our parentheses and we always want to use our x values. And so the first one that I see is, I always read my graph from left to right because that just makes sense. That's how we read, right? And that's going to help you. If you always go from left to right, it's going to help you out. So from -5 to -3, that's the first place I see that this is going up. So -5 to -3, it's going up. Where else is it going up? Well, I'm going to keep going over from -1 to +1. It appears to be going up. And this little spot from 4 to 5, it's also going up. Okay, let me talk about notation for just a second. I can see how this would look confusing. That if you were just looking this out of context, you might think that's a coordinate. This looks like 3 different coordinates. They're actually intervals. How do we know that they are intervals? Well, just like in reading, you have to think of things in context. You're going to have to think of things in context because it does look like it could be a coordinate. Another thing is this little U sign, and you've seen it already on this paper so far, that means union, and it's kind of like and. So it's here, and here, and here, okay? Where is it going down? The first place, I start on the left and I read left to right. It's going down from here to here. Well, where is here? Here is -infinity. Now, you might be confused and you think that actually looks like positive infinity, Mrs. Reed, because it's up there. But remember, we're talking about our x values. And so our x values says -infinity is over here. So from -infinity all the way over to -5, it's going down. And where else is it going down? From 1 all the way over to 4, it's going down. And then that's it. There are no other places where it's going down. And so you might be asking about the flat places. The flat places, we call that constant. That's what's going on there, is it's just a constant rate or a constant whatever. Back to like the profit from your company, let's say. You had the same profit that whole time. It's just a constant rate. So that's what's going on the flat parts. It's not increasing or decreasing. It's just constant. The last thing we always want to do in the notes is we want to write ourselves a summary. This summary is going to help you remember things. When we go back and study for our test or a quiz, you would want to have this written down so you could go back and review it. It helps us right now to write down a summary because that just kind of solidifies it in our brain. Another thing is on your notes, anytime you have questions, write down questions in the margin. So right now, if there were things you didn't understand, write it down. If it was about this graph, write it down next to this graph. If it was about this graph, write down your question, because that way, when you have questions, you can bring them to class. And I'm going to start class by saying, what questions do you have on the notes? And if you have questions, you go back to your notes and you look, oh, I forgot, but actually, page 3, can we talk about page 3? And then I'll answer your question. So make sure you're writing down your questions in the margins. And that's the end of our lesson for 1-2.